Thank you, Marcy. This is Jeff Morrow from Lendlease. Good morning to those of you on the West Coast, and good afternoon to everyone else. Hopefully, we can keep you engaged throughout this presentation as we discuss what we've learned thus far with mass timber and what we're trying to do and how the industry is moving forward. So we're going to kick it off first off with the first question of the day. Hope you don't have to study too hard for this one. And Marcy, can you take it away?
I certainly can, if I can get the button to work. Sorry. All right, here we go. Profession: architect, engineer, code official, fire service, or other. No matter what profession you have, we are so glad that you're here. Everybody that is in these professions helps us here at the AWC and with our mission in supporting the wood industry. So. And again, as usual, I give about 30 seconds or 80% voting. And I have both of those. So I'm going to go ahead and close. And let's see, we've got 65% engineers, 20% code officials, and then 7% architect, 6% other, and 1% fire service. So again, welcome to all of you. We are so glad that you're here. And Jeff, take it away.
Thank you, Marcy. So here's the outline of what we're going to try and discuss over the next hour. CLT projects around the world, CLT in the Americas, why CLT, and what's next. Next couple slides have to do with the course description and the learning objectives. We will move on through those. So I'm with Lendlease, and we are a multinational company, and our North American headquarters are based in New York, and we do a lot of development, construction, and we do community development and infrastructure development and investment as well, all around the country, and predominantly in a lot of the large city markets, such as New York, Chicago, LA, San Francisco, Boston. And here's a sampling of the projects of what we've done in the past all around the country, ranging from mass timber to the Statue of Liberty renovation, City Field for the New York Mets, the Grand Central Station restoration, Museum of Natural History, high-rise, low-rise projects, everything in between. Lendlease has developed and built quite a lot of those over the years. And the next slide shows a location of where our offices are around the country, and I am based in Nashville as part of our Timber and Innovations Group, and we support all of the timber initiatives utilizing mass timber around the country for our regional business units. And then also our Nashville office is part of our partnership with the P3 partnership with the U.S. military, where we have our privatization Army lodging program, and we service all of our military projects out of Nashville as well, ranging with services from everything from design to development and construction. The next slide showing a location of the projects that are going to either have been completed or under construction or about to be constructed utilizing CLT for the U.S. military. We completed 2 years ago, we completed the first CLT hotel in the United States at Redstone Arsenal. Last fall, we built Fort Drum, New York, a hotel there, and then in October we will begin construction at Joint Base Lewis McChord up in Tacoma, Washington. Next winter we will be in Fort Jackson, South Carolina, and then in 2020 we'll begin construction of several hotel buildings at Fort Bragg, North Carolina, all utilizing CLT as the primary structural material. So for us with Lendlease, our journey and exploration into CLT began around 6 years ago, when we started to explore it for a project that we were doing for a redevelopment in Melbourne, Australia. And we started utilizing it on Forte. It was a 10-story project, 9 stories of CLT over a 1-story concrete podium. And it was a residential development that we were doing in Melbourne, close to the waterfront. And we were doing a lot of redevelopment of the whole that whole area. It has been converted from an industrial area to a more residential and commercial area. out near the waterfront. And that got us a lot of attention at the time because it was a groundbreaking project for Lendlease as well as the mass timber movement at the time being the tallest. And for the most part, for the mass timber superstructure was concealed with drywall, with the exception of the occasional accent wall in the living unit and then the underside of the porches, as you can see from the picture here on the left. And then the next picture will show a rendering of the penthouse with some stairs leading up to the roof. And with you see the wood floor here, and this is not a CLT floor, this is a hardwood floor that has been added after we've built up the floor assembly for acoustics. But you can see for the most part, it's a very modern looking apartment with a lot of painted surfaces throughout. We did leave the occasional glulam brace exposed as an architectural effect for certain units where those were located, and you can see that on this picture as it finishes uploading here. Apologies for the lag. And then shortly after that, as part of our redevelopment in Melbourne, we developed and built a 3-story library and community center called Library at the Dock. And we utilized cross-laminated timber for the floor panels and the roofs. And we utilized glulam columns and beams as the vertical members to help support the structure. And with the picture you see on the left is the exterior, and that is a metal rain screen that is painted to look like wood, but that is not exposed timber on the outside. We expose the timber for the interior. So between the development at Forte, where we use CLT for walls and floors, and then we opened up the space using columns and beams, for at the library, we all of a sudden had several different types of building structures where we could use it for different purposes for residential and office space and the like. Here's a picture of the monumental stairs as they were coming in, and you can see an opening, an interior view of the books and the meeting spaces for the library. There we go. Bit longer lag this morning than this morning's presentation. My apologies on that. And then over in Europe, we started to do multiple developments as well. We started to do a 6-story apartment building called Cobalt Place in London. And for the most part, everything was concealed with drywall there as well, but we did leave the underside of the floor panels exposed, and we put a whitewash stain on there for an aesthetic effect. But for the most part, this CLT was concealed, and it looked like most of your other typical buildings in that area. And then 2 years ago, we began construction on a project in Sydney of the 7-story office building out of mass timber glulam columns and beams with CLT floors, and it was called the International House. And it was in the heart of the central business district with a lot of exposed glulam columns and beams. And we also developed that whole parcel of area around it with the high-rise concrete towers. And so Lendlease believes in utilizing all the different materials for the different variety of different applications. And in the shadow of these large concrete towers, we have a smaller, more boutique office building out of mass timber, the 7 stories there. And so some of the next few slides are going to be showing some pictures of it during construction when I was on site there to see how the pieces were going in. One of the advantages of this building was because it was lighter than concrete. It was on top of an existing parking garage. And so the loads imposed on the parking garage were less than if it had been a concrete structure, which gave this a valuable opportunity to utilize timber in this particular parcel of the entire development. Here's other couple of pictures showing some of the knife blades for the connections of where the columns and the braces would connect as well. And then when it was finished, this is a picture showing the completed project. And with a glass facade, exposed structure timber on the interior, as well as exposed MEP systems that were all painted black for a more stylistic look. This building has been fully rented out, has been a success for Lendlease as well as its tenants who've moved into the space, and we will begin the construction next year of a identical building on the mirror image of this on the other side of the pedestrian bridge. You'll notice that in the picture, there's a bridge going across the road. On the other side of it is another small parcel where we're going to be putting a mirror image of the same building, also 7 stories. But currently, right now, we're in the process of building a 10-story office building in Brisbane, which is considered to be the tallest commercial office building out of timber currently in the world at 10 stories, 9 stories of office over a 1-story retail, and it is slated on track for completion in November of this year. There's a picture of the structural frame as it was going up a few months ago, with the floor panels going on top of the glulam beams. And the next picture is going to show you some of the pre-assembled wall panels being lowered into place. And you can see in this picture where the openings for the doors and the windows have already been pre-cut into the panels so that we don't have to do those cuts and openings in the field. And then the next picture was taken just a few weeks ago as it shows the completion of the structural assembly with the glass facade coming up right alongside it. The building is on track for completion in 3 more months' time. And here, the next picture is showing an interior view of the completed portion on the interior with the exposed glulam columns and beams and the CLT floors. The top surface of the floors will eventually be built up with other finished materials, but the underside will be left exposed. And you can also see when you look at the glulam beams, you can see holes already pre-drilled in there for piping to penetrate through there at specific locations. And you can see the elevator openings on the far right where we did the shaft walls out of elevators, out of CLT. Next year, we're beginning development of a $1.2 billion development in called Waterbank in Perth, Australia, and at least 1 to 2 of those buildings will be CLT. And here's a rendering of the proposed CLT office building will be going in there. This development will have a combination of concrete towers as well as some CLT mass timber structures sprinkled throughout, and this is what one of those buildings is intended to look like once it's fully developed. And we're also beginning construction of a development in London called the Timber Yard with multiple high-rise timber residential structures with retail on the first floor in an urban infill project there. But one of our most noteworthy projects right now is we've broken ground on the new headquarters for Google in London, and they are building an 11-story building. We will be building it for them with a 2-story basement, and it will utilize CLT for the floor panels and a lot of glulam columns and beams as well. And it's near King's Cross Station in the heart of London, and it's going to be 870,000 square foot for gross. And it's going to be our largest CLT mass timber project to date in terms of height as well as area. And the next picture shows an interior rendering showing the glulam columns as well as the CLT floors and the assemblies. It's quite a fascinating and unique project where the floors step back. Every 3rd floor is full width, and then they taper back to allow more light in, and they repeat again. It's pretty interesting. So that leads us to our second polling question. Marcy, can you take it?
Absolutely. So the international projects discussed, all of them utilize cross-laminated timber, CLT. Is it true or false? So go ahead. I've got about 50% of you and about 15 seconds, so half and half. All right. Let's go. We've almost got 80%, so I'm going to go ahead here, and I've got it. Y'all seem to have stopped voting, so I'm going to go ahead and close. And let's see, 92% say true and 8% say false. So I'm hoping that those 92% are right, Jeff. What do you say?
Yeah, that is correct. All of them are utilizing CLT for the floor assemblies. Some of them are using for walls, but often some of the other, for the more open layout space situations, we will be using glue lams columns for that. So after seeing what's been done globally for Lendlease, we are not quite as ambitious to date with what our current projects are. But we started in earnest back in 2015 when we started to do the Redstone Arsenal Candlewood Suites hotel project. It's a 4-story, 92 key room hotel that's at Huntsville, near Huntsville, Alabama. And it looks like a very generic looking hotel that you would see off the side of the highway interchange. There's nothing special about it. And the funny thing is when you walk on the interior, you don't notice it's CLT either, because it is all the drywall is, the drywall conceals everything, and nothing is exposed. So here we also completed with Woodworks. Woodworks applied for a grant, and we helped build the 3 different CLT structures from manufacturers from 3 different North American CLT manufacturers, and we assembled those and we put them at Tyndall Air Force Base, where they were subjected to multiple rounds of blast testing to see how CLT would perform in a blast environment. And this was important for us because with our hotels that we build on military installations, those buildings are considered a high-value terrorist target. Ever since the 1983 Marine Corps barracks bombings in Beirut, sleeping quarters for soldiers and military personnel have been considered a terrorist target, where a devastating disaster at a building with soldiers in it could cause massive casualties. And so our buildings for the house of soldiers must be designed to comply with ATFP, anti-terrorism force protection measures, and to resist progressive collapse in the event of a blast event that would be a chemical fertilizer truck bomb in a parking lot, or a briefcase bomb brought inside the building. And so the buildings, to be blast resistant for that, we needed to have additional research to determine the performance characteristics of what CLT could do in a blast, so that we could design the buildings to be a safe dwelling for our soldiers. And then in the spring of 2017, we assembled a 2-story. We partnered with the American Wood Council and assembled a 2-story apartment building test structure at the ATF lab in Washington, D.C. And it was built out of CLT materials that would be used for a 10 to 12-story application. And we subjected the building to multiple different fire tests to see how that would perform. And I'll go into a little bit more detail on that further into the presentation. But so to date, we've done one hotel, we've done several test structures for blasting, and we've done a fire test as well. And then from there, we moved on into Fort Drum, New York, where last fall we began construction on a 4-story hotel at Fort Drum, New York. And if you've ever been to upstate New York, that part of upstate New York, it's about an hour and 15 minutes north of Syracuse, and about 30 miles from the 50 miles from the Canadian border, and 30 miles off of the Lake Ontario. And so we get subjected to lake effect snow a lot. And we started construction going vertical in October on Halloween, and we finished in March. And I would never, ever recommend having to go vertical in upstate New York in the winter, where we dealt with 10 feet of snow and 15 to 20 inches of rain during that time. It was a tough building environment for us to build in, but we're able to prove and validate that we could build CLT in any weather. We just stopped working there when the temperatures dropped below minus 15, because it wasn't because of the wood, it was because our fingers, the workers, were getting just too cold to work below minus 15. And then we would have to shut down when the winds whipped up off of Lake Ontario and would retreat an 8,000-pound CLT panel like a kite when it was hanging off of a crane. So when we had high winds, we'd have to shut it down as well. So more of our delays were due to wind than it was to the cold. But here's some pictures of the project on a cold, wet, rainy day in January, where you can see a sheen of water on the floor slab. This is, I believe, on the 3rd floor. You can see the wall panels, the exterior wall panels being braced up. You can see the joints in the floor where the where the floor panels abut each other, and you can see a part of a shaft wall there and onto the left-hand side. And the next picture showing the picture on that same day as the sun was starting to set, and you could see the third floor walls going around the perimeter, the guardrails there, and you can see the stair shaft walls on the far left-hand side. Here's another picture of the third floor operations where you can see one of the floor openings for the mechanical ducts. You can see all the windows and the doors have already been pre-cut out of the wall panels as well. And that day was about 38 degrees, and then the next day it dropped down to 12. And then we had a little bit of dusting of snow overnight, and so then everything always made it for a little bit challenging when you woke up in the morning and wondering when the storm system was coming through, what lake effect issues you might have. Because oftentimes we would wake up and the next morning we would be greeted anywhere between 12 to 18 inches of snow on the structure. So then we would have to spend a fair amount of time removing the snow just so that we could get back to assembling the structure and setting the walls into place. And so much to the point that oftentimes we use our snow blowers more often than we used our hammers. That was the most valuable tool on the project, were these two snow blowers to help us clear the snow. And we had over 120 inches of snow, 10 feet of snow during our framing operations. Next picture is showing what the project was looking like after we finished the structural completion with the barrel vault roof. So you can see the parapet, the walls going up past the roof on around the perimeter, and you can. But it was a good project in that it proved that we could build in any weather. And when we started to compare our results of this hotel versus a similar size hotel of Fort Bliss, Texas, that was built out of metal studs, we found out that this building built in the dead of winter, we built it faster and with fewer people than a metal stud structure in Texas that didn't have to deal with the weather constraints that we were subjected to at Fort Drum, New York. So today we've completed the one hotel at Redstone Arsenal, 4 stories, 92 rooms, and that was completed in 2016. And our pipeline of work is showing as the future Fort Drum, the ribbon cutting is scheduled for this November. And we have Joint Base Lewis McChord in Fort Jackson and Fort Bragg in 2020. And so we've completed 1 building so far. We have another 6 in the pipeline. And so for a total of 7 buildings with over 1,000 hotel rooms being built out of CLT over the next couple of years. And the picture that you see here below is a picture of the typical hotel room that we provide of what we deliver to our client, where the beds, and you have a kitchenette for cooking. And it's an extended stay type of hotel because a lot of our guests from the military are there for anywhere from 2 weeks to 5 months for training. And they have their per diem and they can stay in our hotels. And it's an extended hotel where they can cook and do their own meals as needed. So that's our typical hotel room around the country of what we're delivering for them for the brand standards. And then you can see here again on this map where the installations are across the country that are going to be utilizing cross-laminated timber. We're building in all sorts of geographic areas and a variety of climates as well, union and non-union, and it's proven to be a good structural solution for us and for these, in particular, for these applications. Which brings us to our next polling question.
It sure does. By 2021, how many hotel buildings in the U.S. are projected to be built utilizing CLT as the primary structural material? Is it 2, 4, 7, or 8? If you were listening, I heard Jeff say it. So hopefully y'all are listening to it and not have us on in the background. All right, I've got 30 seconds and I'm going to go ahead and close. So 46% say 7, 31% 8, 21% 4, and 2% 2. So Jeff?
The answer is 7 by 2021. We will have already one completed, and we have 6 more scheduled to be delivered. So for us, for CLT, Lendlease builds buildings out of all types of materials. We do high rises in Manhattan, Chicago, LA, and San Francisco with concrete all the time, and we will continue to do that. But why do we think CLT is a potential useful tool in our toolbox for some of the projects we either are looking to develop or build? And one thing we're inspired by is our company founder said back 45 years ago that companies would eventually be judged not only economic basis, but the other impacts that they have on the environment around them, environmental and social impact. And so sustainability is a characteristic that we strive for, of trying to, when we create the best places for our clients. And CLT helps us with that. And what we found out is that when you start to have whenever you're looking to develop your project, when you have certain constraints, we're beginning to, we're saying that you should at least give CLT an opportunity or consider it to see if whether or not it might be a viable solution for you as a structural material for your project. And every project's got different constraints and motivations as to why they are going to use, what material they're going to use and how they're going to use it. For us at Forte in Australia, our biggest challenge there was the high foundation costs. The soils in Melbourne, Australia, the project was near the waterfront. The soils were contaminated because it had been a former industrial area, and they had poor bearing capacity. And so our engineers, and we were spending a lot of time and energy engineering solutions for foundations to support our heavy concrete towers that we were building in the area. But we also had to do some shorter buildings. And our engineers had said, well, wouldn't it just be nice if we could build ourselves a lighter building? And knowing that CLT had been utilized in Europe for about 20 years then, we started to go down that path, and they realized that a CLT structure, a 10-story CLT structure, could weigh a fourth of what a similarly sized concrete structure would be. And all of a sudden, if we could go with a lighter weight building, we wouldn't have to do as much for the foundations to support that. And so that was our primary driver there. For us in the United States, when we started looking at incorporating CLT for our Army lodging program, at Redstone Arsenal, we had a serious issue with labor costs and labor scarcity. At Redstone Arsenal, it's a very highly secure military installation where only 2,000 soldiers are active duty military, and then you have 20,000 specialized contractors, engineers, and professionals that work on the installation. All military installations are secure, but Redstone was especially secure in that you had there the Space and Rocket Center. Nearby, you had a lot of missile scientists there. You had the aerospace industry. The NSA was there. The CIA, FBI, and the ATF all had training schools down there. And so you had a lot of high-level, sensitive government organizations that had operations at Redstone Arsenal. And one of the rules was getting onto that military installation is if you were not an American citizen, you couldn't get on the installation without being escorted 24 hours a day. So that eliminated a lot of our available construction workforce. Construction historically has been, the workforce has been a lot of immigrants, and even with documented immigrants, we couldn't get them legalized. We could not get them in if they were not American citizens. And so that reduced a lot of the available work pool that could be eligible to get on the installation. Plus, because of the sensitive nature of what happens at Redstone Arsenal, all the workers would have to clear a background check. And if you've ever looked at the construction industry and those that work in it, oftentimes they have some colorful and checkered pasts where a background check might be problematic for other members of your workforce. So it was a real challenge for us to get skilled workers that could meet those requirements onto those military installations. More so problematic there than it would be a hotel in the private sector outside the gates. So for us, labor scarcity was an issue. And how do we get the skilled labor? And skilled labor is a shortage everywhere around the country, and so that only exacerbated the situation for us. And we also knew that CLT was a pretty strong material and that could work well for the ATFP measures that would be required by the U.S. military. So CLT can work in a variety of applications for different buildings. And from our perspective, we could see it working in these environments here on this slide here. We could see it in the 1 to 5 story, but it's somewhat difficult to always make CLT pencil in the 1 to 5 story range because of the cost of the material is so much more than a typical light wood stick frame project. Most of our projects that are 1 to 5 stories in the industry are wood stick frame because it's very cheap and very economical. And as a material, as a raw material, it's much less expensive than the CLT just because of the volume of wood fiber that goes into those structures. So CLT doesn't necessarily always pencil out economically in the 1 to 5 story realm unless you have high labor costs or labor scarcity. And then we also know that CLT mass timber structures can go up to 18 stories, as been evidenced by the recent Brock Commons project in Vancouver, British Columbia, 18. There are some taller structures in Europe as well. And then we've also done 10-story buildings in Australia. So we know that can be done, but we really think here in the United States that and this is just our opinion, but we think that there is a deficit of buildings in the 6 to 12-story range. And we think that that's where the sweet spot for mass timber could be, where as your cities are getting increasingly densified and you need to go a little bit taller, that we think that the 6 to 12 stories is probably the ideal, optimal location of where the CLT will most likely be used. Because it is more expensive than stick frame in the 6 to 12 range, it doesn't have to compete against stick frame. It competes against steel and concrete, which in a lot of markets we feel is very competitive. And we think that the 6 to 12 is probably going to be where a lot of the mass timber buildings work best. That's not to say that they don't work elsewhere. Every project has a unique, they have unique constraints, and the clients have unique requirements for what they want on them. But we really think then 6 to 12 is probably where a lot of CLT will be used, especially in tight urban settings where you have limited laydown areas and limited access to the project, where materials can come in on a truck and quickly get unloaded and go into place. Which brings us next to our next question. Marcy.
Here we go. CLT should be strongly considered when a project experiences which of the following conditions: labor scarcity, crane shortage, schedule constraints, all of the above, or answers A and C only. Okay. About 10 more seconds. All right, I'm going to go ahead and close that up. All right, so 79% say A and C only, 16% all of the above, and just 5% in the other answers. So let's see, Jeff, what is the real answer for us?
So for the answer for us today was E, A and C, labor scarcity and schedule constraints. The crane shortage is going to affect you whether you're doing a concrete or steel or CLT building, but the best answers for this would be the labor scarcity and the schedule constraints. What we're finding is that CLT can be a faster medium and can be a faster medium than concrete, especially when you consider the fact that with a concrete superstructure, normally you're on your 4th floor before you can begin removing the shoring and reshoring from the 1st floor. And you have to be up so many stories in the air before your trades can really get to work after the concrete. And with the CLT structure, once your floor panels are down, for that floor, you can immediately have subcontractors begin working underneath that because there's no need for shoring or reshoring waiting for the concrete to cure. So we figure we can pick up a few weeks there on the schedule once that goes. So the benefits for us with CLT is one of the things we've been fortunately able to do is over the last 8 years, we've been developing and building hotels for the U.S. Army across the country. And so we were able to compare the hotels that we've built, the new hotels of similar size and shape to what we did at Redstone Arsenal. And most of our hotels were typically 4 stories and about 92 to 95 rooms. And when we compared those square footages of the other previously completed projects and compared it against Redstone Arsenal, we found that our building was actually 14% larger. This 14% increase in the building was mandated by some programmatic decisions where they decided that the bedrooms needed to be bigger. They needed to have bigger interior space. They decided that the dining area, the common area, the lobby areas, and the back of house areas for operations all needed to be bigger than what we had built before. So when you added a few inches here and a few inches there to the different rooms, and you multiplied that out over all the bedrooms, all of a sudden your building footprint grew by 14%. But when we compared it against metal stud construction, which was what we had always done in the past for the U.S. military for a blast-resistant application, we would normally have had a peak crew of 26 metal stud carpenters. And with us, we had a peak crew of 11 assembling the CLT superstructure. And that's where we thought we really had a benefit there. Once we started to compare, that was a 43% reduction in employees, and we were also building the building 37% faster than our historical average doing metal studs. And we were 44% fewer man hours, and our structural production was up 75%. And when we compared that and our overall schedule by utilizing the CLT mass timber system, and we incorporated the use of prefabricated bathroom pods for the guest rooms, all of a sudden we were able to shave 3 months off the schedule, the overall schedule, which meant our client had the project 3 months faster. There were 3 months less of general condition expenses, 3 months less carrying costs on the property. So eventually these things all started to factor in as positive benefits for the project. Actually, we would have had finished the project in 11 months' time, but 2 days before a TCO inspection, our electrical contractor drove a lightning protection grounding rod into the underground duct bank that provided power feed for the building, and it set off a fire. When the transformer didn't shut off from the utility company, it didn't shut off power to the building. It arced power into the panel gear inside the building, and we had to replace that with it caught fire, and we had to replace that as well as the transformer and make a repair to the underground duct bank for the power feed. And we lost a month getting everything removed and replaced. So we would have actually shaved even more time, but even with that, even with that incident, we were able to save 3 months off the schedule. So when we start to look at sustainability, we look at it across 3 different guidelines: economic, environmental, and social. And what we found is when we did our analysis that the CLT structure was 37% faster than our traditional metal stud construction for these blast-resistant applications, and it was also cost neutral to that. And then with the thermal massing of the building and the VRF energy HVAC systems that we put in there, the building was actually 31% more energy efficient than our previous hotels of that same size. And the mass timber structure also sequestered over 1,200 tons of carbon, which we thought was a nice plus. And then also it helped from a social sustainability perspective. You know, I mentioned that we assembled the building with a maximum crew of 11 guys. Only 3 of them had been trained carpenters, and the other 8 were unemployed Army veterans that we hired through a job placement agency, trying to find, get help for veterans. And we upskilled them in the construction trades. And so we assembled that building in roughly 11 weeks with 11 guys, but only 3 trained carpenters. And the rest were former military veterans that we trained on the job to learn the product. So it helps us address the labor shortages that we're seeing in the industry. And it helps us, build up our workforce where we are having a definite deficit of that. And we are also eliminating the exposures to falls for our workers from elevated heights by doing the guardrail system on the floor panels before we fly them into place. So when we start to look at mass timber and what it can do, the product's been originated in Europe about 25 years ago, has been making its way to the United States. And so a lot of architects, and hopefully I don't insult any of the architects who are listening in today, but a lot of architects start dreaming about what they could do with timber, how they could showcase it as a building material and make it go, and how far can they make the material perform. And right now, as the beginning of the industry, in terms of the design and construction, for the U.S. market, this is kind of where we are. We're at the very beginning. We're still learning, but we've learned a lot of good things, and we can make a lot of neat projects out of CLT, but I would encourage those who are looking to explore CLT is to follow the KISS principle for right now and learn and grow. Do a crawl, walk, run approach as you work on your designs and do more, as you expect more out of the material, as well as the installers who will be putting it together. Because from our perspective, CLT we think is a market disruptor in terms of the thought process as to how you design, build, and deliver a project, and it requires a whole different mindset and approach as to how you're going to do it. And this is a picture from our Redstone project where you can see our corridor walls were CLT. They were 3 inches thick. Our demising walls were 4 inches thick between the rooms, and then we also had CLT floor panels that would be 8 feet wide by 50 feet long, and they would span across multiple hotel rooms. And so we have a 400 square foot panel of floor set every 10 to 12 minutes, and you can see the guardrails there already there for our guys. Here's a picture showing the project as we were putting in another floor panel. You can see the guardrails are already in place, and our workers are already working they're working safely from height and eliminating the exposure to falls. As you can see this picture of the panel going in. It's about an 8,000-pound panel, 400 square feet, and we were setting those about every 12 minutes, sometimes 15 minutes, depending, as depending. So, but you can see the panel's already in there with the guardrails, and the workers are already working from a safe environment. So we start to look at what's next in the industry. What are we trying to do? How is the industry moving forward? So in the spring of 2017, we began assembling a 2-story apartment building test structure at the ATF Research Lab in Washington, utilizing a North American CLT manufacturer. And these are elements that were built out of for a building that would be for a 10 to 12-story application. And each floor represented an apartment with a kitchen in the living area in one room, and then you had a sleeping area in the other room. And we had mirror images of the same thing from each floor to the other. And then on the 2 sides of the building, we had a corridor that wrapped around as a hallway. So, and on the roof, if you look closely, you can see tanks that are on the roof that are filled with water to simulate loads of other floors that would be above it for a 10-story application, so that you can see how the building was being subjected to those forces in the event of a fire. We couldn't go any taller than 2 stories because that's as tall as the exhaust fan would allow us at the research lab. So we did everything we could to simulate the building loads and what the fire conditions would be. And if you look closely at this picture, you can see that room is really chock full of a lot of available fuel. It's all IKEA furniture with a lot of wooden shelves, and then they put a lot of other wooden cribbing in there to act as a simulated fire load. And there were books and other things in there. This building was subjected to 5 different fire tests over several months. It would take us a little bit of time to do some demo, repair, and rebuild it for another test. But in this test here, you can see a view of the fire starting in the kitchen, and then a few minutes, I believe about 10 minutes later, the entire living area is consumed. And then a while after that, the fire spreads over, and you have flashover into the other sleeping area. And the purpose of these tests were to see with the fire, how would the fire behave in a CLT structure? Would the fire go from one floor to the next? And they didn't. And would it go into the hallways and cause any other issues there? And it didn't. And in most of these tests, we left the windows out of the fire tests. And most of the time, we let the fire self-extinguish and burn without applying any water to them or sprinklers. But we did simulate a few of those to see what would happen. And when we did activate the sprinklers, the fire damage was minimal, especially if the sprinklers are activated at the first detection of the smoke, or if we did a delay, the damage was still quite minimal. But in this particular fire, we didn't activate any water protection. And several hours later, all the contents of that room, of that apartment, had been severely extinguished. I mean, they'd been self-extinguished. They consumed all the flammable materials, except for what you see a flame on the far right. On the far right, that wall was a CLT wall that was left exposed, just to see how an exposed wall would do under the fire. And so several hours into the fire, we had that. But with no sprinklers activated, this is what the fire did. And there's a lot more information about this report, all these different tests and how they perform. And And all this information was gathered by the American Wood Council, and they've summarized it, and they have it on their website at the awc.org/tallwood. And it talks about all the 5 different tests, all the scenarios that were run, what were the results. This was the most heavily censored fire test conducted by the ATF lab in their history. There were over 300 sensors in this 2-story structure to see exactly how the heat transfer worked from room to room and from floor to floor. And you had thermocouple sensors placed at different thicknesses into the wood, penetrations into the wood, to see how was the fire. If the CLT panel was on fire on the interior face, what was happening to the heat of the CLT panel 1 inch in from the fire, 2 inches in from the surface, 3, 4 inches in. And so we captured all of this data to see how well wood was as an insulator from extreme fire, extreme heat temperature changes. If it was hot on the inside, what was on the other side of the wall. And we found out that the wood worked very, very well. So these test results, combined with a variety of other tests that have been conducted over the last few years in North America and between Canada and the United States, a lot of test results were forwarded and collected together, and they were submitted to an ad hoc committee that was sponsored by the ICC. There was an ad hoc committee to explore the idea of going for taller timber buildings after seeing what was happening in Europe as well as in Australia. Could the ICC develop a framework of proposals and regulations to allow for taller timber buildings, and how would that be done? So these test results, as well as the fire test that you just saw, were gathered to the committee. And this committee consisted of experts from all over the country, ranging from timber suppliers to concrete industry, the Masonry Institute, and the Steel Institute, as well as the drywall industry, architects, engineers, fire marshals, a lot of other building code officials that were all together. And over the course of 2 years, they debated all the different results and proposed revisions to the building codes to allow a framework for taller timber buildings. And so what they proposed is what you see on this slide here. They proposed that the current Type 4 codes as we know it be relabeled as Type 4 HT, and then that doesn't change. What you're used to seeing in Type 4 stays the same. And then they proposed 3 new subtiers, Type 4A, B, and C. And each subtier represents a different classification for the allowable height and areas and number of stories, and then what the performance of the building must be. So you could go with a Type 4C where the timber is fully exposed and the structural frame must be 2 hours. And then if you go to Type B, 4B, you could go taller, but you now have to start encapsulating some of the materials. You cannot leave it all exposed with your specified fire performance. And Type 4A, which you could go up to 18 stories, but everything is fully encapsulated with non-combustible materials. So your structure, your CLT mass timber structure would be completely encapsulated and not exposed, and with a certain fire performance there. It should be noted that Type 4C was listed there on the table with an 85-foot height with up to 9 stories. There was a committee modification to that just recently that changed that to a maximum of 8 stories because it was very, very difficult to try and squeeze in 9 stories when you only have 85-foot building height. So that has been modified to max out at 8 feet instead. At 8 stories, not 8 feet. My apologies. Let's see here.
Jeff, if you're there, I think we lost your audio. So if you want to send a chat in the control panel there, we'll see what we can do to correct that situation. You may need to dial back in.
Hello, I'm back. Sorry about that.
Good.
Sorry. All right, moving on. So my apologies on that. The Tallwood Building Ad Hoc Committee proposed 14 different changes to the building codes, and the first 8 you see here are listed here. to all the different sections, and then you see the remainder of those 14, where a variety of different parts of the building code were going to be changed from allowable building height, area, and number of stories, all the different parts that make up the building code. This is where the revisions were proposed for the different tables and data. And this is all detailed in much further detail in the awc.org's website /tall mass timber. All the detailed that you could, far more detail than we can go into this call. So when we look at the ICC procedure, there's 8 steps of the development of the I-code development cycle. And January 8th, the ad hoc committee submitted their final proposed language to the ICC. And then it was up for public viewing. And then in April, there was a committee action public hearing held on this in Columbus, Ohio, for a variety of different officials from around the country, and advocates testified in support of these proposals. And then they also heard those who were not necessarily in support of this. There was a floor discussion, and the committee voted nearly unanimously with one dissenting vote in support of the recommendations proposed by the Tallwood Building Ad Hoc Committee. The recommendations were sound. They were based in logic and science with a lot of testing to back it up, and the committee here also agreed with it. So after that hearing, the proposed changes went back out for the public viewing again, and those public comments will be posted later on at the end of this month. And there will be public hearings in Richmond, Virginia, the last week of October, and then in November, there will be some online voting of registered building officials, government building officials, that will vote in favor of, or will vote on these proposed measures. They were all prepared by the ad hoc committee, then they were voted and approved by the ICC committee, and now the general voting public at large has an opportunity to vote on this. And then hopefully in December, the announcements will be posted via CDP access as to if this passed. So for some more information about what these code changes are and what they're proposing, I just gave you a thumbnail sketch of that. You can go to these 3 different websites to talk about what is happening, what they are proposing, and the logic and the rationale behind it. And I encourage you to look at the iccsafe.org website, where it shows all of the meeting minutes of what they have done in the past and what they were proposing. And you can see who the committee members were that on the ad hoc committee that developed those recommendations. Build Tall, Build Safe also talks about a lot of different information about timber and the benefits of it as well. And then this YouTube video is good as well. For those of you who are interested about the blast performance of the CLT and what has been done with that with Woodwork's efforts, there are several different links here with the videos as well as the publications as to what has been done and the press releases and the information about it through two different rounds of testing that occurred in 2016 and in 2017. So for us, Lendlease as a developer and a builder, we do a lot of different types of buildings with a lot of different types of building materials, and that's not going to change. We still find there are places for concrete and steel, and we'll be building that for a very, very long time. But we also think that there's a place for timber, and as we're seeing the need to use timber buildings, we really believe that these code changes are a positive change and a welcome change from our perspective. And I think it could help move the industry forward, especially for architects and engineers and clients who do not necessarily want to go down the AMMR path. That said, the proposed changes that have just been proposed for the ICC for the 2021 building code revisions have been voted and immediately adopted for immediate use by the state of Oregon. So the state of Oregon is already incorporating these guidelines as a supplemental to their building code, and they're adopting it as right now. And they can use that for taller timber structures. Other states are considering it, and then some other states are going to wait to see what the ICC does in October and November, and what the results will be in December. So if you think that CLT is a material that should be considered, and you want to have that as a tool in your toolbox as a designer, engineer, or as a developer, the idea, if we can get a proposed framework for what taller timber buildings would be that have been thoroughly researched and vetted by industry experts from all different facets of the market. We think that the taller timber buildings are a good idea. I have no aspirations of doing an 80-story timber tower. I'd like to do a lot of 6 to 12s. And the building code, the way they're doing it, is a very conservative. The proposed recommendations are a conservative framework for how that would go to do those structures. And I think that it's an opportunity for everyone to have another tool in their toolbox as to whether or not that's for an idea for their upcoming development. So if you know a code official, and they may not have heard about the idea of taller timber buildings, let them know that this has been done. It's been vetted by 2 committees. It's ready for a vote, and that it has been well thought out. This wasn't a half-baked idea by a bunch of tree huggers who wanted just to use trees instead of concrete. It has been a thoroughly vetted and tested and analyzed in a conservative framework to move forward. Which leads us to our last and final question, the question you've probably all been looking for.
Okay, so here we go. For certain occupancies, which is true regarding maximum height and number of stories for proposed types of construction? Is it type 4A can be 270 feet and 18 stories? Type 4B can be 108 feet and 12 stories. Type 4C can be 85 feet and 9 stories, or all of the above? All right. Okay. Not so many people are voting for this one, so I'll give you just a couple more seconds. And I'm going to go ahead and close. All right, there we go. It was delayed there a little bit. All right, so 80% say all of the above, 10% type 4C, 85 feet and 9 stories, and 9% 108 feet, or sorry, 180 feet and 12 stories, but no one says 270 feet and 18 stories. All right, Jeff, let's find out what it really is.
And the answer is all of the above. Now that said, C is a little bit tricky because we just found out after we did the webinar this morning that committee modification changed it to 85 and 8 stories. So, but the best answer, the ideal best answer was supposed to be D, all of the above. Those are all the categories of the heights and stories, with the exception of the clarification to type 4C. So, moving forward, what are we trying to do? Earlier we saw this slide showing the spectrum of where the mass timber industry is. Where do some people want it to go? And one of the interesting things is for a long time, we built with concrete and steel, and it was always just a structural material only to be concealed and covered up. And only in the recent few decades have we decided to have architectural concrete and leave the steel exposed. The same thing could be said for a little bit on the timber. But where I find that I think the big change is going to be in the built environment in terms of how we view CLT is when we see it like this. When we see it as a common and everyday building material that can be used for a variety of applications. It's not going to be the perfect application for every project, but it is something that you can do. And that will work for a lot of people and a lot of needs. CLT, mass timber, we think can work for a variety of applications in terms of hospitality, residential, office space, business space, a variety of different things like that. When you see it as a more common material, not necessarily a boutique material, it doesn't have to be flashy. It can just be a rudimentary structural material like we see steel and concrete. So with that, we're near the end of the presentation. We've got time for some Q&A a little bit for those of you who can linger around. I know you had an hour commitment, and I want to thank you for your time that you spent with us today.
We do have lots of questions that came in during the webinar, so we'll spend 10 or 15 minutes working through some questions. So Jeff, I know one of the things we tried to anticipate were some questions about electrical, mechanical details. There are also quite a few questions about sound, attenuation, acoustics. think you've got some slides showing some details there and maybe some information about STC and IC ratings for some of these assemblies.
Sure. All right. So this upcoming detail that you should see here will show the exterior wall assembly of what we were trying to do there. We had, for this application, the hotel, we had all the exterior walls for CLT. We didn't use a glass facade around the perimeter like a jewel box there. And when you use CLT for your exterior, the CLT works really well with a variety of different facades and materials. And in this case, we utilized brick. Red brick was the choice of the prevailing material for what they wanted to use at Redstone Arsenal. Most of the buildings there were red brick, so we did the same thing to blend in. We did the built-up assembly there. You can see a steel angle there under supporting the CLT. That steel angle there was to provide a mounting system, a perfectly flat system for the CLT to rest on the concrete. Because the CLT is built to a much tighter tolerance than the concrete could ever be poured in the field. And also it gives us a flexible connection for a blast event so that the steel can move a little bit and flex in the blast event for the CLT and to transfer those forces down. So you can see a picture there kind of showing how we did the built up of the exterior wall assembly. And then the next picture is showing how we furred out the walls to allow for two things: for your electrical conduit, for shallow boxes, for your electrical boxes, your thermostat wiring, and also for your insulation, for your noise, for your acoustical performance. So we did 1.5-inch stud furring there, and with insulation in there, mineral wool insulation. And with that, we had quite a good acoustical performance for our STC performance for the walls. And the walls are supposed to meet an STC of 55, which in the field we could test a few points less than that. And then in the field, we actually tested 5 points above. So we tested at 60 in the field, and the building was actually quite remarkably quiet there. But you can see how we furred out the walls there. And then the next picture is showing how we did our drop ceilings. We went very conservative for this one 3 years ago, where we put a layer of 5/8 Type X underneath the CLT floor assembly as a 7-inch CLT floor slab. And in some cases, we direct applied the Type X drywall to the underside of the slab, and other times we furred it down a little bit, as you can see in this picture. And then we had a further drop ceiling at 9 feet for the sleeping areas and an 8 foot for the foyer and the bathrooms. And so our floor-to-floor height, I believe, was about 11 feet, and then we did a drop with the drop ceilings to get down there to 9 feet and 8 feet. And you can see that assembly there. What we found out was the STC assemblies for the floors, they tested at 61 in the field when the 55 was designed requirement, and then the IIC was really quite exceptional at we scored a 72 in the field, and where a 60 was designed. The next slide you will see shows kind of how we built up the CLT floor. We put the 7-inch CLT floor assembly, and then you had an Acoustimat followed by a gypcrete, the 3/4 inch, 5/8 gypcrete. I'm sorry, 3/4 inch gypcrete, and then we put a carpet in on the sleeping area on top of the gypcrete, or we put the resilient flooring in the entryway foyer. So with that assembly on top, and then with what we did with the drop ceilings down below, we had quite a robust acoustical performance so that you didn't really hear your neighbors. And our Army client really appreciated that. You couldn't tell it was a CLT building from the outside or from the inside because everything was encapsulated. But once you were inside the building for a little while, you realized it was a little bit different from your traditional hotel because it just seemed that everything was so quiet. And that was a really nice benefit from our soldiers, especially since they're not staying there just for one night or 2 nights. They could be staying there for a couple of months at a time for their training. And so that was something that the Army really started to value. So those are our details in showing how we kind of built up the assemblies for the walls and the floors. You don't want to have everything exposed because it will present some acoustical challenges, but you have to be judicious with where you want to expose and what you don't. And then the building code framework proposed for 2021 also helps give you the framework for that, for how much can be exposed depending on how tall you want to go with your building.
Great, great. So you mentioned connections a couple of times. Talk a little bit about proprietary versus standard connections. And then I've got a specific question about the knife plates that you showed in one of the projects and whether they used self-tapping screws for those knife plates.
Okay, yes, we use self-tapping screws everywhere, or we use nails as in certain applications. Some of these hold-down plates, like on this particular picture, you see the L-shaped bracket, that would be nailed in for that connection bracket here on this picture. So you use a lot of different nails there. We also used a lot of partially and full-threaded screws, depending on the application, and they were all self-tapping screws that you would drive in with an 18-volt max, D-walt, and you could drive those in. Those screws range anywhere from 3 inches to about 21 inches in length, depending on what the application was. If you were doing a simple, wall-to-wall splice connection, or if you were doing a, wall-to-floor connection and you were kind of like using a toe screw application, and you were having to go through the floor into the wall panel below, shaft walls and different things like that, you would use a variety of different screws in different locations. So most of the screws right now tend to be European made because the Europeans have been utilizing this material technology for a lot longer than we have. The American manufacturers are starting to pick it up. But there are different screw suppliers and distributors here in the United States that sell that product. It's not, I will say right now, it's not the typical screw you can go buy at Home Depot or Lowe's for a weekend project. They are a specialized high tension screw that can really maximize the strength of your connections for your timber-to-timber structures. But a lot of them have been standardized. It's just, you can see that in the CLT handbook as well as some other publications. And so it's not necessarily proprietary, but they are unique connectors than what you're used to seeing for traditional light stick wood framing.
Great. Speaking of suppliers, we had quite a few questions about CLT suppliers in the U.S., and I was able to find one location, the APA website, apawood.org, provides a list of CLT manufacturers, and there are about 7 in the U.S. Right now. So since that was asked several times, I want to make sure I address that one. Jeff, talk a little bit about the approval process that you went through for some of these U.S. projects. I know they were DoD projects, but talk a little bit about working with engineers, code officials, all the various folks involved in that approval process.
Okay, so on our military projects, since they are military installations, oftentimes they were their own authority having jurisdiction, and a lot of those installations didn't have their own in-house building officials. And so we would be required to, under our agreement, we have a third-party agreement with Bureau Veritas, where they are our code consultants. They're an independent code consultant who verifies that what we are doing, what we design, develop, and build are in accordance with the latest codes. And so all our design documents go through them, and then we have to, in our submissions to them, we dictate how we're going to build the materials and how they are co-compliant. So the first few hotels that we've done, they were all the Type 3B. They were all within the constraints of using wood as a material. We just used heavy timber. We used the CLT and some glue lam in that project, but under the Type 3B classification, and it was 5 stories or less, and that's how we submitted it. And there wasn't a lot of concern. It was just more of a curiosity as the newness of the material. But the fact that CLT has been recognized in the building code helps. That definitely helps, so that we did not have to go down the AMMR pathway because it was all within the current code constraints.
Great. Also, quite a few questions about moisture, during construction, and then some of the New York slides or the New York project. You showed some snow and then moisture on the floor systems. Talk a little bit about how that affects the CLT panels and what is done to the product itself to mitigate that.
So the CLT doesn't absorb water like a traditional wood framing does, and that may be hard to process at first, but with the way the glue adhesives work between the different layers, if if the wood wants to move in one layer in one direction, you've got the wood, the next layer, the grain of the direction is going in another direction that doesn't allow it to want to move. And so dimensional stability works really quite well. And what we found is that even working in wet environments and cold environments, that the CLT doesn't necessarily absorb the moisture like you might think it would. And it does dry itself out. One of the things we did is before we put any more materials on it, we would run fans into the building to circulate air to help dry it out and to make sure that the materials were dry before anything else had occurred. But one of the things that we did discover is when we were doing the blast testing structures down in Florida, it was at Tyndall Air Force Base near Panama City, and the project was a quarter mile from the Gulf of Mexico. And it was very warm, very humid the entire year. And after we did the first set of structures, and we blast, with the blast testing, it was decided that the buildings were in good enough shape that they could be reused for the next year. And those buildings sat exposed to the elements and through a couple of hurricanes for an entire calendar year. And there was some staining where the metal straps had rusted due to the elements because it wasn't designed for a saltwater, but there was some rust stains and some discoloration of the timber, but the moisture content was really good. When the sun got on it, it dried out, and there was no moisture penetration past the first eighth of an inch. And we were surprised with no protection how well that building was holding up. And the structure, after a year being exposed, it was still in very good shape. It just didn't look pretty. But we found that the CLT works well in that environment. It doesn't wick the moisture like you would think. It doesn't penetrate the face grain. And if you put a sealer on the bottom of it before you stand it up vertical, that helps a lot as well. So,
great information. Transportation. So are there limits for panel sizes for transportation to the job site?
I would say that for the most part, there's no limits to what the size of the panels are. It would be a matter of the logistics of whether or not you want to go through the headaches of how big of a panel do you really want to transport. Every state's got different requirements as to what oversized loads must be escorted, and they may require permits for that and maybe accompany escorts. So ideally, you would want to keep your panels within the regular constraints for loading for your trailers. And for our panels that we had on Redstone and Fort Drum, they were not oversized, so they sit on the panels. They fit on the truck trailers well and move. Nordics panels would be 8 feet by 64 feet long, but we would typically only put in an 8 foot by 50 foot panel for our floors and our roofs. And that extra 14 foot that would come out of the press would be cut up and used someplace else for material resource efficiency because you don't want to waste that material. But 8 by 50 fits very well on a tractor trailer. I think once you get above 10 feet, then you're considered oversized, and then you may have to deal with different permits to get that through. So for North American, you probably don't want to go any wider than 10 feet on a bed to avoid the permitting loads. But if you want to, you can. But then if you are utilizing European product, then you're dictated by the size of what those shipping containers are when they come across on the boat. And those panels have to fit inside those shipping containers and then be unloaded later. And so your panels from Europe typically are smaller than they would be from North America because they just typically are smaller. And then you have to unload them out of the container as well. Whereas on a North American delivery manufacturer, you can get your panels reverse loaded in the order that you need them so that the panel on top is the first panel that you need and just work through the stack. And once you get to the bottom of the trailer's empty and you've just gone in order of what you've needed without having to double handle your materials. So there are some transportation constraints, but if you wanted it bigger, you could. It's just whether or not you want to pay for the headaches of the permitted loads and working through those logistics.
Great. So one of the slides talked about some of the advantages of CLT and mentioned ATFP standoff. Can you elaborate on that a little bit more, maybe cover that again?
So with ATFP standoffs, the anti-terrorism force protection standoffs, depending on the type of building material your structure is made of, you have to have certain setbacks from, let's say, your parking lot or your street to your building. So then, in the event that you had a fertilizer truck bomb, that depending on its proximity to the building, how much damage it could cause. And so concrete is your strongest performing material for that. They have the smallest setback allowed, and that works exceptionally well. But with a light stick frame, you could be at 120 feet setback from a parking lot. And with CLT, we're finding we can get closer to about 40 feet from a setback. So you're getting closer to the performance of concrete for setbacks, but without maybe not the cost premiums that could go with concrete, depending on what market you're in. And gives you a lot more flexibility as to where you're putting your parcel for your setbacks. And metal studs have a greater setback than that as well. So, and then depending on what your exterior veneer and your facade is, also can influence how far your setbacks can be, depending on the total assembly of your exterior wall. So, but we're finding with the CLT performance, it's really working quite well. It opens up a lot of sites for us that had been previously difficult to develop and build on when you try to figure out where you're going to put your parking lots with the constraints of where your streets are and your underground utilities that you may not be able to build over. And that now we have something that could be faster and cheaper than concrete, with a lot more flexibility than if we had done it out of metal studs. And previously for our hotels, we did not build out of wood studs. We built them out of metal studs because for the blast performance requirements and the setbacks that the metal studs could allow us. But now CLT is better than that. So we like what that extra flexibility that it can give us in certain options and markets.
Jeff, thanks so much for sharing your expertise with us today. It was an excellent presentation. Thank you all for being here, and we hope to see you again next month for our durability webinar. Have a great day.
Thank you.